This is one of my new studio lights. It's an LM-8 100 watt monolight from Interfit. I ordered a pair of these about 3 weeks ago. I've got one up on the stand on our left as our key light, about 2 meters away. And what I'll do through the video is to put down in the left hand corner here the camera settings and also the light settings, distance and modifiers on the light, that kind of thing, so that you can see how well it's working. I do have the fluorescence on behind me, but that's really the main source of illumination. The fluorescents at the front of the workshop are all off. And as you can see, it's fairly bright. It's actually operating on 80% at the moment. So let's take a look at this. First off, what comes in the box is your light here, a little manual with a couple of spare fuses, and a 3 meter power lead, which I've managed to misplace already. I have loads of them, it didn't even make it out of its bag. So at the front of the light, we have the cover, and that's on a Bowens S-type mount. If I pull the latch back, and this is a very smooth mechanism actually. I do have a load of photography lights for which I have accessories, and that's one of the attractions of this light, is that I have so much Bowens fit kit that I don't really need to buy any. But putting this on and taking it off is very, very smooth. You just push in and turn and click. So we have a Bowens S-Fit ring at the front. This ring on the outside is for the fold down soft boxes. Now, Interfit sell these up to 4 foot by 2 foot. I do have one of those, not the fold down ones, but I have a 4 foot by 2 foot soft box, and I was wondering whether I could replace it with a fold down. And it turns out they do sell them. I don't use that size of soft box very often, or at least I haven't in the past. Ordinarily I'd use I think they're 3.5 foot octagonal soft boxes and a 2 foot by 2 foot square box. But I can definitely see those in my future because they're much easier to put up and take down by the looks of it. I've forgotten how much of a pain they were. So at the front here we have our chip. That's supposed to put out 100 watts of light. In fact, I don't know if it'll show up on the camera here, but these are 2 discrete chips. There are 2 50 watt chips on there. They have their own power supplies and their own drivers in the back here. And if this cover were removed, you'd be able to see the 2 pairs of contacts, so you have positive and negative on each side. So as we move back, we've got the heatsink, which is 90mm in diameter and 60mm in depth. That's a lot of metal to dissipate the heat from our chip. Behind that is the fan, and that's stood off of the heatsink. It's not bolted directly to it like it would be with, say, the Godoxes, the SL60s. I don't know the rationale for that, but this thing is fairly cool in use. You can pick it up after you turn it off. It doesn't get blindingly hot. Though I'm pretty warm standing in front of it, but the actual unit itself stays fairly cool. The body is made of metal as well. The 2 ends are plastic, and these plastics are actually very strong. They don't feel brittle. They're not, not really flexible. They feel pretty sturdy. The whole thing feels very well made actually, despite the price. So if we move further back, we've got the dimmer control there. You have a little window there which displays the percentage of output you're on. On-off switch, and the socket for your power lead. At the bottom here is the stand mount, and that is, I think that's 1mm steel. I haven't checked that, but it looks like 1mm to me. It's all folded, very sturdy, And the actual mount itself is cast, again, very thick, very sturdy. This thing really does feel like it's built to last. And as you'll see when we test the output for the chip, or the power output for the chip, it does look like it's very repairable. I don't know if you could get spare parts, but if you can, well, it's very easy to fix, I would imagine, if something goes wrong. So at the bottom here, like I said, we have the stand mount, and the only part of the light that feels cheap is this lever here and the locking knob, and they're just not very nicely moulded. They're sort of quite cheap things. If you're going to save money anywhere in the production of something like this, I suppose that's the place to do it. They don't have to be particularly strong. Not so they feel weak, but the tilt locking lever, it just feels cheap. It wouldn't cost a lot to replace these 2, and I might do that. It's really just vanity. I think it's quite a nice light, and it would be nice to have nicer fittings on there. But really, it doesn't matter. They work well enough. Now we're going to go through the spec sheet, and we're going to see exactly what this light should be doing, and then we can move on to actually testing it. So at the top of our sheet, this says maximum power 100 watts. We're going to pop this apart, grab a multimeter and some leads, and see how much power we're getting to the chip from the drivers. The colour temperature and CRI, I can't test those. Now this is a 5600K colour temperature, so it's daylight. It looks like daylight to me, and certainly on the monitor above the camera, everything looks, well, like it would in the sun. Looks very, very nice. The same with the colour reproduction. Looking at the monitor, that looks like the same colour on there as it does to my eyes here. So looking at the benchtop, that's all subjective though, so take that with a pinch of salt, but I don't have the kit to test those. Maybe that's something we can come back to in the future, if I ever buy the equipment. It says it's got a stepless dimmer knob on the back. Yeah, probably. The readout is in 1% increments, but it certainly doesn't seem to step down when you turn the knob. It seems quite smooth, so yeah, probably. 220 volts, it's pretty standard forever except the States, I think. And the stuff that we can test here, so the lux at 1 meter, 2 meters and 3 meters. This is probably really what we're interested in. How much light are we actually going to get out of this? So at 1 meter it says 14,100 lux, and I don't think it does put that out. I have the feeling that's more like a half a meter figure. At 2 meters is 2,290. Again, I feel that's probably a 1 meter figure, and 3 meters 993 lux, and again probably 2 meters. But we'll see. I don't know whether these were tested with a modifier on there. The lamp wasn't supplied with one. There's no dish with this, and looking at the product information sheet, it does say that this comes with the fold down softbox. I'm not sure what size. This one didn't. It wasn't on the product description page or anything, but in the manual it says it should do. It doesn't come with, like I said, it doesn't come with a dish, but we have those, and we will test this with and without and see how much difference that actually makes. From the figures that I've seen, this would compare fairly favourably to something like a C120D Mark II, but I haven't got one of those to test either, so I'm a bit wary of comparing this to other lights when I haven't seen them myself. But I will show you a sheet later on that I've made up that has some figures for a couple of other popular lights. So now what we've got to do is take this, pull it apart, and see how much power we're actually getting out of our chip at the front here. The first thing I'm going to do is to take this cap off and give you a better look at the chip. Get this under the camera, and you should be able to see there the two discrete chips and their terminals, and they run back to the drivers in the body here. So we'll pop that cap back on, and we'll get these screws undone, preferably without knocking the microphone boom. And that's one. There are only 3 screws in the back. I have to say I think this thing's quite well built. It's very simple to take apart. It looks very serviceable. I don't know if you could get spares for the electronics, but certainly easy enough to take apart and put back together. No, there's a lot of plugs, not a lot that's soldered. The leads aren't all soldered in place. Anyway, you'll see that in a second. We now pop this out and see where I've forgotten to put one of the leads back. We have the 2 driver boards. You can just about see the second one underneath there. There's I think a MOSFET here and a power transistor on the other side. If I lay this a bit flatter, you'll be able to see that it's a fairly chunky transformer there. There is another one down here, and these 2 have toroidal transformers on them. These boards also have what I think this chip is the PWM controller. There's no writing on it, there's no stamping, so I'm assuming it's a custom chip. And these are PWM controlled. There is a line from our dimmer knob there that runs through a cable, this white cable here, to these boards. So everything is done on board here. They just take the power supply from that transformer, I suppose, and these are run on 36 volts. Whether that means they're supposed to pass 36 volts to this chip, I'm not entirely sure, and this is where things get a little, I think complicated is probably the wrong word, but I'm not confident that a multimeter is going to give us the most accurate result. This is my multimeter. It's about 10 years old. I've had this for so long. It might even be older than that, actually. I bought it from Farnell years and years ago. So I have the invoice somewhere with the order that came on. And yeah, it does frequency, so we could sort of check the frequency, find out what the duty cycle of the PWM is. We could, if it went beyond 20 kilohertz, which it doesn't. So this thing obviously switches very, very quickly, which is good because it means you're going to get, or you have less likelihood of having strobing when you're filming video. But it also means you can't measure it with this. It's a bit of a pain. I think an oscilloscope would have been the thing to have. I don't have one. It has been on my list for a long time. But I've never got around to actually buying one. So we'll keep looking through eBay, I think. And maybe we'll revisit this at some point. So we get this plugged in, we'll check the voltage on that top driver, because I know that the measurements are actually very close. We'll get this turned on, get our light on, and up to, if you can see that, 100%. Yeah, you can see that. And our 36 volt feed is down here, so this one here is that's our 36 volts, and the one next to it is, not that you can see that on the camera, that's our 36 volt, that's our ground, and they're very, very close together. There's not a lot of separation there, but then it's 36 volts, it's a relatively low, I imagine it's relatively low amperage as well. So we want to be careful which one of these terminals is which. So that will be, if we trace this up there, that will be our 36 volt line. And must buy an auto ranging multimeter. 28.9. It's a bit odd. Ah, sorry. Yes, I should have mentioned. It runs on 36 volts. But the measurement we get from these two terminals is 28.9. 28.8. Usually 28.9 to 30. Okay, well 28.8. Usually between 28.9 and 30, but okay, we'll settle for 28.8. So I'm not sure whether this being PWM should be putting 36 volts to the chip, because with PWM control, essentially it just turns off and on very, very quickly. But we're not seeming to get that at these two terminals, and again, I'm not confident that this is a good way to measure this, so like I said before, pinch of salt, and don't forget to remove the cover on the LED before it melts. Oh wow, that's very soft. Don't do that. I think this is a consequence of having done this a few times now. I'm starting to lose the plot a little. Okay, right, we're going to measure the amperage now. Means we have to turn the light off. And this is roughly in line with what I've got written down from doing this a couple of times already. We'll plug in a test lead. So if you're measuring amperage, you need your meter to be in line with the load. You can't put it in parallel. needs to be in series. Which would have been a bit of a pain. I did think I was going to end up having to either cut a wire and then solder it back in. As it turns out, it was, you know, these little plugs here. I've got loads of these. Plugs and sockets from various projects over the years. Make sure if you've got, well, your multimeter will tell you, but put these in the right place. And then set the right range if you haven't got an auto ranging meter. So this is a fairly cheap thing. It was only about 15 quid at the time, I think. Don't know what that would translate to now. Okay, and that gives us 1.5 amps, which works out to about 44 watts. If we assume that both of these drivers are the same, and they're close enough, that gives us 88 watts of power rather than 100. But then we would have to assume that our measurement method was correct. And I'm not entirely sure it is. Well, I keep repeating that, it's because I don't like being uncertain of these things. I think if you measure something, you should be reasonably certain that it's correct, or that you're within a, you know, you have your margin for error. It's a little frustrating to look at something like this and think I'm not certain the way that we're measuring this, the method is correct. But just say it were 88%. Sorry, if it were 88 volts. If it were 88 watts. Just say it were 88 watts. That's about 12% down on where it should be. That's quite a significant difference. However, the important thing really is how much light that puts out, and is that in line with what the specification says. And that's what we're going to test next. But of course we have one of these lights set up already. It's the one that's lighting the bench at the moment. We do have the fluorescents on in the workshop, which help, but they don't provide all that much light. The bulk of the light is coming from the other one of these, and that's turned down to about, it's actually under halfway, it's about 40%. So you can imagine it's putting out rather a lot of light. It's not a dim thing, and that's got a softbox in it on top of it with that has a softbox on it with both the inner layer of diffusion material and the fabric covering on the front. So you can imagine that's reduced the light by a few stops as well. So when I say these are bright, they really are very, very bright. They're not going to overpower the sun, but they're certainly quite impressive so far. I haven't done the light tests yet. So I had gone through this a few times, done a few takes of this. The lighting tests I haven't done at all yet. So that's going to be the interesting bit, and that's what we're going to do next. Our lighting test setup is going to involve putting this Hagner S2 photometer onto a stand and putting it more or less just behind where the camera currently is. There's a line marked on the floor with half, 1, 2 and 3 metre increments marked on it, and with this light on another stand we'll be moving it down those marks towards the photometer. We'll take readings as we go, and I'll point the camera at the scale here so that you can see what's going on. We're going to start off doing this without the dish on there, and then we'll do it with the dish. So I'm going to get this moved out of the way and we can get everything set up. This is our first test with our bare light. It's at 3 metres away, there's no modifiers on there, and its twin is lighting up our scale here. Now, it's about 60 centimetres away, and it's about the same distance from the microphone, so we'll see if the mic picks up the fan noise. I can't say as that seems to have been a problem before, but I think this is quite a good test to see how close you can get to it without picking it up. Bearing in mind that this is a shotgun mic, it's very directional. It's the AT875R. We'll see how that goes, but let's get our photometer turned on. And nothing on the 10,000th scale. 1,000, and that's 100, so that gives us about 350 lux. at 3 meters. Now I'm going to go move that stand to 2 meters and see where we're at. I've moved the light to the 2 meter mark. We're going to turn our scale around. It's registering on the thousandth. And we're looking at about 7,100 lux. Now I'm going to move this to 1 meter. With our light now at 1 meter, let's see where we are. It took a bit of fiddling to get that right. And we're at about 2,500 lux. Yeah, 2,400, 2,500. 2,400, I think. Now we'll move to 0.5 meter and see what we get. Well, that was a bit of a fiddle to get set up at 0.5 meter. We got there, within about 5 mil, hopefully. And if we flick our photometer on, and that puts us at about 9,600 lux. So, yeah, 9,600. Now we're going to get set up with the dish and reset this and see how much of a difference it makes to our measurements. Okay, that's our light reset to 3 meters, and if we turn our dial around, that gives us about 780 lux, which is considerably more than it was at 3 meters without the modifier. Now I'm going to grab that stand, take it to 2 meters and see what the next result is. Now at 2 meters again, and that puts us at about 1,600 lux, I think. Oh, it looks like 1,600. Perhaps 1650, we'll call it 1600. I'll get the light moved to the next position. Back again at 1 meter. And that's just over 7,000 lux. Looks like 7,200. Yeah, 7,200 lux. And now our last luminance test for our light before we move on to checking the beam angle. And immediately that's jumped up to about 35,000 lux. Probably close to 34. We'll call that 34,000 lux. Now we're going to check our beam angle. And to do this, we've got our light here mounted on a homemade stand, and that's sat on a rotary table. Our light sensor is at this end of the bench. The distance doesn't really matter, we're measuring an angle after all. And essentially we're just going to turn this on and rotate it until the scale there reads, well, whatever the minimum is. So if we turn this on, we can see that we're at about 600 lux. So we're going to turn this on and turn it until the reading hits 600. And that's our beam angle. That's not necessarily our useful light output, but it tells us just how much spread this has. And from the looks of it, actually, it's fairly broad. So if I turn this on, I should have worn my sunglasses for this, shouldn't I? It's very bright. We're set at 0. We're going to rotate this that way, towards me, because I enjoy being blind. And you can see it's starting to fall off. And about there is where we're at. So if we check our reading, we're at about, in fact we are at dead on 82 degrees. And we'll run this the other way. So we'll run this back to 0. Try not to look at the light. That's zeroed out again. We're reading 3,100 lux in total on there. And we'll keep running it this way until we hit about 600. It's about there. And again, 80 degrees, give or take. So it's about a 160 degree beam angle. We can try this with the dish on there. We know that that improves light output significantly if you're directing it at something specific, or if you need to use your light to illuminate something further away. So I'm going to go this way again. Oh, wow, hang on. We'll check our zero reading first. 7,500 lux thereabouts. So probably about a metre away. Oh, and that looks like it's where the needle stops moving. And that is 40 degrees, so really nicely halved the beam angle there. And we'll go the other way just in case. Ooh. Out there. And yeah, we're about 40 degrees again. So that's an 80 degree angle. So we've got 160 degrees and 80 degrees. Now I want to get everything put away, pack up for the evening, and come back tomorrow and finish this video off. Well, it's a new day. Actually, it's a new night. I waited until dark so I could set up the lights all on their own. We've got no other lighting in here, all the fluorescents are off. And I'm going to put the settings for each of our two lights on their respective sides. Now, we've done our tests. We did the electronics test. We looked at how much wattage we're getting from the chip, and that came out to 88 watts. About 12% below where we wanted to be. I'm still not 100% sure of the methodology there. I can't be confident in the result itself. However, I did say in that section that what really matters is the actual light output and how these things work in practice, and that's why I've set them up like this. So we're going to go through our lux test results here, and you'll see it on the table up here. I have this printed out so I don't have to read that from the back. And we'll go through with the unmodified and modified tests respectively. So at half a metre we were reading 9600 lux and 34,000 lux. At 1 metre was 2500 lux and 7200 lux. 2 metres was 710 lux and 1600 lux. And at 3 metres was 350 and 780 lux. The beam angles were 160 degrees and 80 degrees modified, with a 20 degree hotspot essentially before the fall off begins. So that's a lot of numbers, and they're really only useful if you want to compare them to something, and so I did. I've chosen the Godox SL60 and the Aperture SL C120D Mark II because they seem to be firstly quite popular and secondly often compared. Personally, I'm a little bit dubious of comparing the SL60 to the C120 because it really doesn't seem like much of a competition there other than on price. So we'll start off with the Godox, and the only reliable figures I could find for this were firstly at 1 metre, and they were on a Lighting Hire website, a studio Lighting Hire website. They said that the manufacturer's figures were off and that they had done their own tests and that these were the results. So that was 2000 lux unmodified and 4500 lux with a reflector. That's as compared with 2500 unmodified and 7200 lux with the dish for ours. That's quite a significant difference. And we'll get onto whether that difference is worth it in a second, but that's a big difference in light output. And actually, if we compare the Godox to the C120D, we can see that that's 4700 lux and 7000 lux. So while our LM8s are slightly brighter with the reflector on them, overall the Aperture lights are putting out a hell of a lot of light. So let's have a look at the Aperture lights now. We have 9600 lux unmodified compared to 18,000. It's putting out almost twice as much light. And bearing in mind that it is supposed to be a 180 watt chip on the C120D as compared to our 100 watt. Well, yeah, you'd expect to be putting out 80% more light, and it's a much bigger figure. Of course, that's slightly different when we put a dish on there. All of a sudden, we're putting out 34,000 lux and the C120D is at 30,000. This may be to do with the particular dish that they've used. It might be different to the ones that I've got. I don't know, but it certainly seems that with a modifier on there, these are a match. They're not hugely brighter, but they are slightly brighter. We see much the same result at 1 metre. Ever so slightly brighter with a modifier, but almost half as bright without. At 2 metres, things are much more even. We've got 1600 lux and 1700 lux, so not a huge difference. I couldn't find a 3 metre figure. Of course, the comparison doesn't really end with the light output. It's also about price. The Godoxes are about £130. These are presently £160. I didn't pay that for them. I got them on sale. And the apertures are significantly more expensive than that. I'm not entirely sure of the price off the top of my head, but it's probably in excess of £500 or £600. They also kind of serve different purposes. If I had the money, would I buy the aperture? Well, no, because for my use case, it's just overkill. It has DMX control, lighting effects, a really nice remote control. And if I would say anything, it's that the SL60 and the C120D both have remotes. These don't. And as much as I didn't think I'd want one, I kind of do. Having put this video together, I've realised that it would be really, really useful to be able to control these remotely. That might seem obvious in hindsight, but having been running around twiddling with the dimmer controls, I think if I was to do this again, I would be looking for a light with a remote. In terms of light output, though, I'm really happy with these. I wouldn't ordinarily be using these without the fluorescence, I don't think, or without some supplementary lighting. Fluorescent lights make great fill lights because they put out a really diffuse light. And I've really only set this up so that it's an example of how these particular lights work on their own. Overall, I'd say I'm happy with them. I think they're pretty good value for money. They're significantly brighter than the Godoxes, and I think that's fairly important. But really, it's, as I say, about performance, and they perform well enough for me. I hope that doing a comparison like this, or actually just providing some figures, some meaningful measurements, has been really useful. If you've actually made it this far, thank you for watching. And yeah, I hope this has been informative.